Hello everyone, I'm Enoch, and today I'm going to be introducing you all to MATLAB. So this is hosted by HKN or AD Academy, and we have e-tutoring on Mondays and Fridays from 10 a.m. to 3 p.m. in Engineering 467-127, or from 5 p.m. to 7 p.m. on our Discord, and the link is here on the slide. There's our website as well. For more workshops, social events, and professional events, you can like and follow us on Facebook at UCLA IEEE HKN, or you can follow us on Instagram at UCLA HKN. So to get started, what exactly is MATLAB? MATLAB stands for Matrix Laboratory, and that's exactly what it does. Everything in MATLAB is either a matrix or an operation on a matrix. MATLAB is not the most computationally optimal language, as its runtime is extremely slow. What MATLAB does excel at is crunching a whole bunch of numbers all at once. If you need to do some prototyping, plotting, or simulation work, MATLAB is probably the tool for you. In most cases, it will make your life a lot easier. So today in this tutorial, we're going to be going over MATLAB's graphical user interface, MATLAB operations and index and syntax, flow control in MATLAB, scripting, and writing functions. So to start off, to get MATLAB, you can go to softwarecentral.ucla.edu/MATLAB-get-MATLAB if you haven't downloaded it already, and follow the instructions listed on the website to get it onto your machine. Now that you've installed MATLAB, let's start off with the basic interface. Please keep MATLAB open for the duration of this workshop. It is strongly advised that you use it to follow along and pause the video as you need. Anyway, the default interface, we're going to start off with the command window, which is A. The command window shows the commands and their subsequent outputs and displays them. B, or the workspace, shows where variables are stored and remembered. C is the command history, which is a list of previously entered commands.
Here are some basic commands you can try entering into the command window. Try typing in these phrases on the slide, such as Y, logo, close, etc. It's pretty cool.
Anyway, basic calculations. If all you want out of MATLAB is a calculator, then MATLAB can do that just fine. So for some basic arithmetic, you can try inputting 10 times 2, some constants such as pi, I, or j for you electrical engineers. There are also some functions such as square root, sine, exponential, absolute value, or inverse. You can also store values as variables such as a equals 10 times 2, b equals a plus 5. And those values will be stored in those variables, just like you'd expect out of a programming language, like, for example, C++. Here we have the Pythagorean theorem being shown in MATLAB. We store a in 3 and b in 4, and c is a squared plus b squared, square root of that, as you expect from the Pythagorean theorem. The semicolon after the a equals 3 and b equals 4 suppresses the output, which means it won't show the value immediately after. In contrast, when we type c equals without the semicolon, it displays the value 5. Clear then clears the workspace, and CLC clears the command window. Some other basic commands include resetting, and these commands fall into that category. Clear removes all variables from the workspace. Close all closes all open figure windows. CLC clears the command window, as I mentioned earlier. You can also Google functions online documentation. MATLAB is very well documented. There's an entire website for that. You can try help sum to see usage of the function sum, for example. You can also hover over the function, click F1 for documentation. The cruise command lists all the variables in use. You can also use the percentage sign to comment, tell MATLAB that the remainder of the line should not be executed. In MATLAB, everything is a matrix. MATLAB is called Matrix Laboratory after all. As proof, you can try entering the command size1. Here's what you get. It's 1, 1. This means that the number 1 is actually a matrix of dimensions 1 and 1. Here are some various methods of creating matrices in MATLAB. To explicitly define a matrix with one row and multiple columns, such as an array or vector, separate values by the commas or a white space. Here we have matrix A, 1, 2, 3, 4, 5, semicolon, which creates a 1 by 5 matrix with values 1, 2, 3, 4, 5. To define values by row, use a semicolon between values. We have B1, semicolon, 2, semicolon, and so forth and so on until 5, which creates a 5 by 1 matrix. To create 2D matrices, use commas or a white space between elements in each row, and semicolons used to separate rows. All the white space shown here is optional. You don't need new lines after each semicolon to denote rows. It's only that way to make it visually easier to digest. Here, for example, we have A, 1, 2, 3, semicolon, 4, 5, 6, semicolon, 7, 8, 9, which separates it into a 3 by 3 matrix. So now here is your first exercise of this workshop. Create a 2 by 4 matrix that looks like this: 1, 2, 3, 4, 5, 6, 7, 8. And please pause the video and try to create this in MATLAB. Functions can make matrices too. Here is the rand m(n) function, which generates a matrix with dimensions m by n of floating point values ranging between 0 and 1. The ones function generates a matrix whose elements are all ones, and zeros generates a matrix of dimensions m and n whose elements are all zeros. These are examples of functions which we will talk about later, which basically take an input and they produce an output based on those inputs. Now here's our second exercise. I'm using functions to create a matrix. Challenge is to create a 2 by 10 matrix of ones. As a hint, use the ones function. Now we're going to go over some matrix math. Basic operators: plus, minus, and multiply are matrix operations. Plus and minus are matrix addition and subtraction, and asterisk is matrix multiplication. For example, here we have this matrix B, multiply B times B, and the answer is shown here below. If you've tried matrix multiplication by hand, you'll probably know from experience that it's a pretty difficult process. And here in MATLAB, instead of just laboriously sifting through all the values, you can just simply type out your matrix, multiply them, and it'll show the answer right there. So that's pretty cool. There's also the inverse of the matrix, which you can get by using the INV function. You just simply enter a matrix, put INV, and you'll get the inverse matrix. There's also the transpose of a matrix, where you can use an apostrophe after the matrix you want to transpose. The division slashes, backslash, and forward slash are used to solve matrices. If ax equals b, then x equals a slash b, which is mathematically equivalent to x equals inverse a times b. And if a equals b, then x equals b backslash a, which is mathematically equivalent to x equals b times inverse a. If you've taken linear algebra, you'll know that this x equals b equation is extremely important. And with MATLAB, you can do that with just a few clicks and typing on a computer, instead of laboriously shifting through all the equations and canceling out your variables and stuff like that. You can see how MATLAB is a really powerful program, and that is greatly preferred by the industry. Our next exercise is to solve this equation. X equals a, where a equals ran 2 by 2. And what is x? Solve it using MATLAB. And as always with all these exercises, please pause the video, take some time to solve it, and pause it when you're done, so we can go on to the next topic. Now we're going to be talking about element-wise operations. You can also multiply and divide by element by prefixing a period before the multiplication or division operator. So for example, we have matrix A, 1, 2, 3, 4, and A dot multiply A. That just multiplies each element individually instead of multiplying the matrix itself. So as you can see, 1 times 1, 2 times 2, 3 times 2, 4 times 4. We get the squares over there in the answer. And the same for the division. For more matrix operations, you can check out the link here shown in the slide. You can create evenly spaced arrays very easily in MATLAB. One method is to use colons, A1, colon 5, which creates evenly spaced values 1, 2, 3, 4, 5. Then, or you can use A1, colon 2, colon 10, which creates values from 1 to 10, which are spaced 2 apart, like 1, 3, 5, 7, 9. The second method is to use the built-in linspace function. Here we have A equals linspace 1, 10, 5, 5. The inputs to the linspace are the lower bound, 1 in the above example, the upper bound, 10, and the number of evenly spaced points to generate, 5. Linspace is good when you know exactly how many points you want to generate. Colons are good when you want to explicitly specify the period or spacing. Fourth exercise is to create an evenly spaced array of size 20 with only even values. Please pause the video, take some time to look at it. Okay. Now, I'm going to be talking about indexing matrices. How do you go about accessing specific elements in a matrix? The simplest case is single element accessing. For example, we have A1, colon 5, which creates the array 1, 2, 3, 4, 5. To access the value, just type A parentheses 3, which accesses the third value. Now, if you do A parentheses 3 equals 999, that reassigns the value within A at the third item in the array, 299. And now if you call A parentheses 3 again, you'll get 999 because that's what you just set it to. A very important note, all indexes in MATLAB start from position 1, not 0 like in other programming language like C++ or Python. The keyword end indexes the last element in that dimension of the matrix. For example, here we have an array A of 1 equals 1, the first item, and A of end results in 10, which is the last item in the array. General syntax for indexing matrices is A parentheses index1, index2, index3, etc. to index n, where each number indexed is the element in that dimension that you wish to index. For example, here we have A, 1, 2 in the first row, 3, 4 in the second row, so that when we call A 1, 1, that results in the first row, first column, and you get the result of 1. On the other hand, if we do A 2, 1, that calls the second row, first item, so that gives you 3. Here's our fifth exercise, an easy challenge on indexing matrices. Now we're going to make a 100 by 100 matrix of random numbers, and what is the value of the element at row 50, column 75.
It is important to note that due to the random nature of this question, your answer will most likely be different from the solution, which is linked in the description below.
There's also the idea of multiple element indexing. You can access more than one element at a time, which is very handy. You can access all elements at a time with a colon. You have the array A, do A1, colon. That'll access every element in the first row. Here the first row is 1, 2, 3, so it prints out 1, 2, 3, and 4, 5, 6 is in the second row. You can also access a specific range of elements. Here we have A parentheses 1, colon 2 to the end, which specifies the end of the matrix. Here to the end in the first row prints out 2, 3, because from the second element to the end of the first row are the values 2, 3. 4, 5, 6 are in the second row. The general rule for indexing matrices is A parentheses indices 1, indices 2, all the way to indices n, where indices can be one of a few things. It can be array of indexes, for example, a 1 to 10, a parentheses bracket 1, 2, 3, 4, 5, 8, 10, and that will print out basically the entire array. It can be a logical array. A logical array is an array of zeros and ones, where 0 means false and 1 means true. We'll talk about more of this in the flow control section of this workshop. Each one in your logical array becomes an element that you want to index. So, for example, you define A as an array 1 to 10. You have A, parentheses logical, parentheses, and a bunch of zeros and ones. Logical tells MATLAB that your array is a logical array. And then when you basically print it out, it shows that 3, 4, 7, 8, because those are values of where the ones are located. At 3, index 4, index 7, index 8. Now for our sixth exercise, a more advanced problem indexing matrices. Create an array of size 1 by 200 where element is a 1. As a hint, use the ones m, n function. Afterwards, set every indexed element to 0 so that your array looks something like 1, 0, 1, 0, 1, 0, etc. Hint, index with an evenly spaced array. Now we're going to talk about combining and concatenating matrices. To demonstrate this, we have a matrix A, which is 1, 2 in the first row, and 3, 4 in the second row. This is a 2 by 2 matrix. We have B, 5 in the first row, 6 in the second row, so it's a 2 by 1 matrix. And for matrix C, we're trying to combine A and B. First, we're going to combine A and B horizontally to make a 2 by 3 matrix. And here we have A, B in the hard brackets. So that combines it horizontally, and you have C, which is a 2 by 3 matrix as seen here. Now, on the other hand, if we define B as a 1 by 2 matrix, 5, 6, and then we can combine them vertically. Notably, we have C, A, semicolon, B within those hard brackets. The two matrices are combined vertically, as you can see here. Here are some optional exercises on practicing matrices. You have given matrix A equals magic 5, provide the commands to do these whole list of things. So if you want to, you can pause the video right now, or you can just take a screenshot of this to save for later. Now we're going to go on to strings. Strings in MATLAB are basically matrices of characters. Call everything in MATLAB is a matrix. Creating a string is easy. Just enclose some text with 2 single quotes. Here, my string equals, quote, bacon pancakes. So now my string is bacon pancakes. You can also index and concatenate strings just like you would matrices. If you try to call my string from index 1 to 5, and then add on my string from 10 to the n minus 1, you get the text bacon cake. Now we're going to go on to flow control. First up, we have comparison operators. These are things like the and, the or, and short-circuiting the or, short-circuiting. These are basically like logical operators. For example, if the first item in an or is true, then you get the second one is true. Yeah. And then you have stuff like not equal, greater than, and less than. Then there's the if, else if, and else statements. This is the most basic flow control within a MATLAB program. Note that each if statement needs to be terminated by the keyword end. As you can see here at the very end, we have an end line. The condition is a logical expression to be evaluated, such as x equals 5. This double equals is checking for a logical equality. If we had just a single equals, then that would be setting x equal to 5. This is a pretty common mistake, so be sure to pay attention to that. The else if and else statements are optional and are used if you would like your if statement to evaluate multiple conditions. Third, we have switch statements. The switch statement operates the same as in other high-level programming languages. It's most commonly used for jump tables and a list of similar triggering signals for different executions. The selection signal for the switch statement can be an integer or a character. Unlike in C, each case statement does not fall through, meaning you don't need a break statement at the end of each case. So, when you have selection signal is signal 1, it'll just call the case under signal 1 and won't fall through to the other cases. So that's pretty nice. And as always, you also need an end at the end as well, like with the else. Here is an exercise on flow control practice. Write a statement that displays the message ret if a random number is less than 0.5.
Hint 1. To display a message, type dis, parentheses, your message here, whatever you want it to be, in quotes.
Hint number 2. The function randx generates a random number in the range 0 to 1. So with those hints in mind, please start working on this, pause the video, and unpause it when you're done. Next up in flow control is for loops. For loops in MATLAB are simpler than those in C. They are more like list iterations, where iterations are given by an array and the iterator loops through the elements of the array in order of position. Note that the array doesn't have to be an incremental array, it can take on any values. Here's the basic syntax for iterator equals an array in the code below. So here in this example for II is A to B, the array, and then just display II within that array. There's also while loops. Here is the syntax while condition in the code below with the end to mark the end of the while loop. It's important that the code in the while loop must change the variables involved with the condition, or else this will result in an infinite loop. Your code will run forever until you force stop the program. Keyboard will freeze, maybe even crash, and that's not something you want. So be careful when you're using while loops that they don't result in infinite loops. A general word of key advice: avoid loops if you can. Take advantage of MATLAB's powerful matrix operations to replace loops in your final program, unless you don't care about efficiency or if you absolutely need to use a loop to get the job done. Matrix operations in MATLAB will always be faster and are often cleaner than a loop. So keep that in mind. There's also continue and break. When continue is hit, the loop ignores the rest of the following code in the loop and starts the next iteration. A continue statement is also applicable for while loops. Here we have an if condition, continue, just skips to the end of the loop and starts the next iteration. Here's the return statement. When the program hits return in MATLAB, the end of the function automatically returns without the return keyword. The program or the function will end. This returns the control to either the keyboard or the original calling function. Now we're going to be talking about scripts and functions which are stored in .m files. MATLAB program files are called M files and have a .m extension. Programs can be scripts that simply execute a series of MATLAB statements, or they can be functions that also accept input arguments and produce output. MATLAB scripts are useful for automating a series of steps you need to perform many times. They do not accept input arguments or return output arguments. They store variables in a workspace that is shared with other scripts and with the MATLAB command line interface. MATLAB functions are useful for extending the MATLAB language for your application, and they can accept input arguments and return output arguments. Store variables in a workspace internal to the function to use them properly. When running scripts, functions, or loading files, MATLAB will only load from certain folders called the MATLAB path and the current directory. You can see this in the interface. The current working directory is the current folder that you're in. You can see all the files within that current directory. The current directory or folder is located on the left side of the command window. It is the default place that MATLAB will look for files, .m files such as scripting functions, .mat files, images, etc. that you try to load, open, or save unless you specify a full path and file name. The path is shown above the contents of the folder. You can change it there or with the command cd new directory. To get the current working path as a string, use cur_dir equals pwd. Path stores the paths of the folders to look in when you are running commands. Path displays the MATLAB search path which is stored in path.m. If you type path into the command line window, it'll show you the path. For example, here we have a lab as samba2.csd.ucla.edu, etc. A bunch of folders, and that's your path. Working directory. That adds the new path folder to the end of the search path, and remember to enter the new path. That's basically the path command here. Type path, parentheses, path, comma, the new path location in the trees. That'll add it to your search path. So MATLAB's going to work files and know to search in this directory as well. Path, this is new path, comma path, adds new path folder to the top of the search path. So then it'll search in your newly defined directory first for files instead of at the very end. Scripts contain a series of commands. Running a script simply executes the code in the script. To make a new script, go to New and Script below that. Save the script to the location of your choosing. The file will be named yourscriptname.m. Script names cannot begin with numbers and cannot contain spaces, so it is advised that you use underscores instead, and that will allow the code to run. Here's an example of a script that produces flower petal pots. We've got some basic computations here, a bunch of lines of code. We've got a for loop here that executes a built-in polar plot. So pause to wait for the key press and the end of that script. To run the script, type the script's file name in the command line. The above code was saved in myscript.m. MATLAB will look through its path to find the script. Type in my script here, as you see, it runs the script and then it plots the file. Sectioning is a useful tool for code flow partitioning. You can choose to run only a specific section of code at a time. Separate your code into sections. Use 2% symbols. Here we see 2% symbols section of code. End with 2% symbols, followed by the next section of code. So you can run these different segments one at a time. Now we can run the code section by section. As we see here as an example, first part of the code. You have percentage, 2 percentage symbols. Then run again, it'll run this next part of the code. It'll plot x, y, negative g, title it sin x, so forth and so on. Same thing for the second figure after you run again, because that's been partitioned off. Some shortcuts. Here we have Control Enter to run the current section, Control Shift Enter to run the current section in advance, F5 to save and run the file, F9 to run highlighted lines, F12 to enter breakpoint, which causes execution of pause at any given line. Debug mode, which is different from normal mode, F5 will continue, F10 step moves to the next line, F11 stepped in, go to the function, Shift F11, which is stepped out, go out of the function. These can be pretty helpful when you want to debug quickly. Instead of moving around your mouse, you can just simply type a single key on your keyboard. So that's pretty convenient.
Now we come to exercise 8, writing a script. Write a script that first generates an array of 10 random numbers in the range of 0 to 100. As a hint, rand 1, 10 will generate 10 random numbers in the range 0 to 1. Then count the number of elements that are less than 25. And remember what we said about avoiding loops. As an additional hint, the MATLAB sum function takes in conditional inputs, so think carefully how you can apply that, especially with regards to the second task.
Now we're going to be talking about functions. Earlier we talked about zeros and ones. Those are some examples of pre-written functions. Now we're going to be talking about writing a route. Functions must be made in a file named functionname.m, or else MATLAB will warn you about this discrepancy. Function definition line defines the function name and the input and output arguments. The syntax is function output 1, output 2 equals the function name input 1, input 2, etc. It means unique. Functions are like scripts in that when they are called, they execute the code within them. The difference is that functions have variables. They can take in inputs and return outputs. Here, as we talked about, we have the function definition line. Function f is called fact and takes an input n. Computes a factorial value. These are the documentation of that function. Notice that the documentation lines have the single percentage symbol in front of them that basically comments out the line. Below that, we have the function body, which basically is the main code that you're running. Here's another example. So you have function y, average x, and it takes in the parameter x, outputs the average into y. Here we have the main body of the function. And to use that function, in your MATLAB command line, type AV, which is where you want to store the result, the average of the array, which is x. Now for exercise 9, writing a function. Make a function that takes in one array and returns an array of the distance or the difference between adjacent values in input array. As in, if say we have input array, which is 1, 3, 10, the output array is 2, 7, where 2 is 3 minus 1, and 7 is 10 minus 3. These are the adjacent values.
Now for our last exercise on writing a function. This problem will be particularly hard. Given a vector A whose elements represent values of a mathematical function f, for example, A equals f1, f2, f3, f4, create a MATLAB function which returns the minimum order of a function that perfectly models f. And remember, a order is the highest power of the function. For example, the function x cubed plus 1 is of order 3. And as a hint, look up Lagrange polynomials and their coefficients and how to implement those in MATLAB. Thank you all for watching this video. The solutions to the workshop are posted down below in the description. Hope to see you next time.